In this video, we're going to go over the summation formulas that you need to know in calculus, particularly if you want to find the area of a region. So let's say if we wish to evaluate this sum, so it's given to us using sigma notation. So what is this equal to? Now, there is a formula for this type of problem. If you have a constant, c, and if I is equal to 1, and it goes up to n, then it's going to equal the constant times n. In this case, we're adding 8 4 times. So the constant is 8. So therefore, adding 8 4 times is the same as multiplying 8 by 4. And this will give you 32. Now let's work on some other examples. Try these two problems. Let's say I is 1, the constant is 7, and this is 8. And also, let's say this is 9 and this is 5. So the first one is simply going to be c times n, 7 times 8. So that's 56. For this second example, it's going to be c times n, or 9 times 5, which is 45. So that's how you can evaluate a sum if you have a constant in sigma notation. Now the next formula that you need to be familiar with is this one. So instead of a constant, we're going to have the variable I, and we're going to go up to n. So this is going to equal n times n plus 1 divided by 2. So let me give an example. So let's say I is 1, and we have the variable I, and let's go up to 5. So we need to add up all the numbers from 1 to 5. So when you replace I with 1, you get 1. If you replace it with 2, it's going to be 2. And we're dealing with sums, so we have to add everything up to 5. 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10, 10 plus 5 is 15. Now let's confirm that answer using the formula above. So n is this top number, it's 5. So it's going to be 5 times 5 plus 1 divided by 2. 5 plus 1 is 6, and 6 divided by 2 is 3, and 5 times 3 is 15. So as you can see, this will give you the same answer. Try this problem. So let's say if we have 6 times I, where I starts from 1 and it stops at 4. Go ahead and evaluate this sum. So when I is 1, 6 times 1 is 6. When I is 2, 6 times 2 is 12. 6 times 3 is 18. 6 times 4 is 24. Now 12 plus 18, that's 30. And 6 plus 24 is also 30. 30 plus 30 is 60. So that's the sum for this example. Now let's use the formula to confirm the answer. So what I'm going to do is take the constant and move it to the front. So what I have is 6 times the sum of I equals 1 to 4 for the variable I. So it's going to be 6 times n plus 1 divided by 2, where n is the top number 4. So that's going to be 6 times 4, and then 4 plus 1, all divided by 2. Now 4 divided by 2 is 2. And 4 plus 1 is 5. 2 times 5 is 10, and 6 times 10 is 60. So in the end, we get the same answer. So that's how you can use the formula to evaluate that particular sum. Let's try another example. Evaluate this one. So let's say if this is 7i minus 3, going from 1 to 5. Go ahead and try that. So if we plug in 1, 7 times 1 minus 3 is 4. If we plug in 2, 7 times 2 is 14, minus 3 is 11. If we plug in 3, 7 times 3 is 21, minus 3 is 18. Notice that the numbers are increasing by 7. We have an arithmetic sequence, but with a sum. So the next number is going to be 25, and the fifth one, the last one, is 32. Now, 4 plus 11 is 15. And then if we add 18 and 32, that's going to be 50. And then 15 and 25, that's 40. 40 plus 50 is 90. So the sum is 90. Now let's use the summation formulas to get the same answer. So I'm going to write it as 7 times the sigma notation for I, going from 1 to 5, and then minus 3. You want to separate it into two parts. So for I, the formula is going to be n times n minus 1 divided by 2. And for the constant, it's simply c times n, and the constant is 3, so it's going to be 3 times n, where n is 5. So that's going to be 7 times 5, and this is supposed to be plus 1, not minus 1. 5 plus 1 is 6, and then this is going to be 3 times 5. Now I'm running out of space, so I'm just going to continue here. 7 times 5 is 35, and 6 divided by 2 is 3. 3 times 5 is 15. Now 35 times 3, 30 times 3 is 90, 5 times 3 is 15, so 90 plus 15, that's 105. And 105 minus 15 is 90. And so you get the same answer. Now for the sake of practice, go ahead and try this example. Feel free to pause the video if you want to try it. Let's say this is going to be 9i plus 7. So this is going to be 9 times the sigma notation for I, going from 1 to 5, and plus the sigma notation for 7 as a constant. Actually, it's supposed to be 8, not 5. So n is 8 in this example. This is going to be 9 times n plus 1 divided by 2 plus 7 times n, where n is 8. So this is going to be 9 times 8. 8 plus 1 is 9, divided by 2, and then plus 7 times 8. Now, 9 times 9 is 81, and 8 divided by 2 is 4, and 7 times 8 is 56. 81 times 4. 80 times 4 is 320, and then 1 times 4 is 4, so that's 324. If you add 56 to it, that's going to give you 380, which is the final answer. Now let's confirm it using simple addition. So if we plug in 1, 9 times 1 plus 7, that's 16. And then if we plug in 2, 9 times 2 is 18 plus 7, that's 25. And then 3, 9 times 3 is 27 plus 7, 34. So it's going up by 9. The next one's going to be 43, that's the fourth number. And then 52, and then 61, and then 70. So we have 7 numbers now. The last one, 9 times 8 is 72 plus 7 is 79. So let's use a calculator for this. So if we add 16, 25, 34, 43, 52, 61, 70, and 77. I mean, that's 77, but 79. This will give us 380. So we get the exact same answer. Now, let's move on to the next formula. And it's this time I squared instead of I. It's equal to n times n plus 1 times 2n plus 1 divided by 6. So let's confirm that with an example. So let's say if we have I squared and we wish to go up to 6. This is going to be 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared plus 6 squared. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36. Now if we add 1 plus 9, that's going to give us 10. And then if we add 4 and 16, that's going to give us a nice number, that's 20. And 25 and 36, 20 and 30 is 50, 5 and 6 is 11, so that's going to be 61. 10 plus 20 is 30, plus 61, that's 91. Now, let's get the same answer using that formula. So let's erase this. So n is 6, n plus 1, that's going to be 7, and then 2n plus 1, 2 times 6 is 12, plus 1, that's 13, divided by 6. So we could cancel 6, and then 7 times 13. 7 times 10 is 70, 7 times 3 is 21, 70 and 21 gives us 91. So this example confirms this formula. Now the last formula that we need to talk about is I to the third power. So it's going to be n squared times n plus 1 squared divided by 4. So let's use an example. Let's say n is 4. Let's keep it simple. So this is going to be 1 to the third plus 2 to the third plus 3 to the third plus 4 to the third power. So 2 to the third is 8. 3 cubed is 27. 4 cubed is 64. So 1 plus 8 plus 27 plus 64, that's equal to 100. Now let's see if we can get the same answer using this formula. So I'm going to work it right here. So n is 4. That's going to be 4 squared. And 4 plus 1 is 5 divided by 4. So we can cancel a 4, leaving 1 4 on top. 5 squared is 25. And 4 times 25 is 100. So this is the formula for I to the third if you ever need to use it. Now let's work on a few practice examples. So let's say if we have I times I squared plus 4I. Go ahead and try this. Now the first thing I recommend doing is to distribute the I to I squared plus 4I. So this is going to be I to the third power, and then I times 4I, that's 4I squared. And then we could separate it into two separate sums. So the first one is just I to the third power. And for the second one, it's going to be plus 4 times I squared. Now the formula for I to the third power is going to be n squared times n plus 1 squared over 4. And then for the second one, it's going to be 4 times the formula for I squared, which is n plus 1 times 2n plus 1 divided by 6. And keep in mind, n is 5, based on what we see here. So let's plug in 5. This is going to be 5 squared, and then 5 plus 1 is 6. On the right, we have 4 times 5. 5 plus 1 is 6. 2 times 5 is 10, plus 1, that's 11, divided by 6. So at least we could cancel a 6 on the right side. Now, 5 squared is 25. 6 times 6 is 36. On the right, 4 times 5 is 20. Now, 36 divided by 4, that's 9. And what's 20 times 11? So if you have 11 $20 bills, how much money do you have? That's going to be $2.20. And if you have 9 quarters, you have $2.25. So 25 times 9 is $2.25. Plus $2.20, that's going to be $4.45. And that's the answer. Now let's work on one last problem. So let's say if we have I minus 1 squared from 1 to 9. Go ahead and evaluate it. Now the first thing I would do is FOIL I minus 1 squared. So this is I minus 1 times I minus 1. And so I times I, that's going to be I squared. And then we have I times negative 1, so that's negative I. Negative 1 times I is also negative I. And then the last one is negative 1 times negative 1, which is positive 1. So now let's combine like terms. So this becomes I squared minus 2I plus 1. So we can rewrite the problem like this. Now let's separate it into 3 separate sums. So we have I squared from 1 to 9, and then minus 2 times the sum of I from 1 to 9, and then we have a constant. So now let's employ the appropriate formulas. So for I squared, it's going to be n times n plus 1 times 2n plus 1 divided by 6. And then minus 2 times the formula for I, which is n plus 1 divided by 2. And for the constant, it's just going to be the constant times n. And keep in mind, n is equal to 9 for this problem. So on the left, it's going to be 9, and then 9 plus 1 is 10. 2 times 9, which is 18, plus 1, that's 19. Here we could cancel the 2's. And so it's going to be 9 times 9 plus 1, which is 10. And then plus n, so that's 9. Now 9 times 10 is 90. And on the right, we also have another 9 times 10, which is 90 as well. 90 divided by 6 is 15. So we have 15 times 19. And 19 is just 20 minus 1. Negative 90 plus 9, or 9 minus 90, that's negative 81. Now 15 times 20 is 300, and 15 times 1 is 15. So 15 times 19 is really 285. 285 minus 81 is 204. And that is the final answer.